Here we have chapter 3.4, transformations, day 1. I made up this function formula to try to help us understand the different parts of a function and how they cause transformations of the graph. Okay? And what we mean by transformations of a graph is if we have a coordinate plane, I'm just going to draw a coordinate plane here. And in my example here, I use x squared. This could be x, absolute value of x. It could be square root of x. It could be cubed root of x. It could be 1 over x. So any of those function graphs on page 232 of our book. And here, for x squared, the graph is a parabola. Okay, and when we're talking about transformations, we are talking about this starting with this parabola that has the vertex at 0, 0, and having that parabola be shifted to the right or shifted to the left, shifted up or down. It could be reflected or reflected across the x-axis or even the y-axis, or it could be any combination of any of those. So a shift to the left and down, and we can understand how that graph is shifted based on the different values that are in place of A, B, C, and or D. And so we're going to look at each of these values on an individual basis, but then we have to understand that there could be multiple transformations happening at the same time. So if I'm given, and I'm using x squared just as an example, the value of a when it is outside of the function of itself. So like in our case here, x squared, we are not including a in the exponent. So a is out in front. If that is a negative number, the graph would reflect. So the graph reflects across the x-axis. If we have a function where the absolute value of a, so for example, we have g of x equals 3x squared. It could also be negative 3x squared. But the absolute value of negative 3 is greater than 1. So if we have a number out here that is greater than 1, the graph vertically stretches by a factor of whatever number is there. So I put the absolute value of a. In my example here, this g of x equals, we'll go with negative 3x squared. It stretches by a factor of 3. So if the fact that we had a negative there, it would reflect across the x-axis, and it would stretch vertically by a factor of 3. Now, if we have g of x and the value of the number out in front of x squared is between 0 and 1, if the absolute value of that number is between 0 and 1, then the graph would vertically shrink by a factor of 1 over the absolute value of A. So the value would be, in this case, 1/3. So if I'm thinking about a graph, if I start at the origin, if I go, usually would go over 3 and up 9, for example. If I would go over 3 and up 9 normally, and then I was given the function 1/3 of x squared, then my y value would be 1/3 of the 9. So it would now be over 3 and up 3 instead of over 3 and up 9. So that's what we mean by it shrinks by a factor of 1/3. Okay? If b is a negative, so b is inside of the function, and so that would look like negative inside parentheses with the exponent of 2 on the outside, or let's say inside absolute value, the negative would be inside the absolute value. So inside the function, if b is inside the function and is negative, the graph reflects across the y-axis. Okay, so reflecting across the x-axis is reflecting up and down. Reflecting across the y-axis is reflecting left and right, because the y-axis goes up and down. The only way to go across that is to go sideways. Okay, so that's why we are talking about reflecting um, across the y-axis. If b is, if the absolute value of b is greater than 1, so if we have 4x inside and then squared, the graph horizontally shrinks by a factor of 1 over the absolute value of a. So it's the opposite of what you would do if the values are on the outside of the function. So like up here when we had 3, it stretched by a factor of 3. Down here, when I have this 4 that's on the inside, it would shrink by a factor of 1/4. Okay, so instead of going out 4 units and up 1, it's going to only go 1 unit over up 1. So that's an example. It's one, your x values are now 1/4 of what you would normally have. So if I have, to get the y. So if I'm using 4 to get to the y value of 1, now instead I'm going 1 value for x to get the value of 1 for y. Okay, so shrinking by a factor of 1 over the number there. If I have the absolute value of b is between 0 and 1, like in my example here, 1/2, then the graph would horizontally stretch by a factor of the reciprocal of b, the absolute value of b. So really up here, same thing, the reciprocal. So 4, 1 over 4. Here, 1/2, the reciprocal would be 2. So in this case, in my example with g of x equals 1/2 x squared, this would stretch by a factor of 2. Okay? So the other thing to think about is anything that comes on the inside, this affects the x, which is sideways. Anything on the outside, like the A here or the D, okay, those affect the y value, which is up and down. Okay? Now, let me get my blue marker back, and we'll finish this page here. If C, so the C is added or subtracted from the variable. So if the C value is positive, so like x plus 5 in parentheses and then squared, we are affecting this sideways. And because it's on the inside, it's actually going to be the opposite, which would be shifting to the left by the number of C, whatever number this is in our example here, 5 units. So it shift to left by C units. Okay, so I guess I already have the C over there. In my example here, this would be left 5 units. If C is a negative in the graph, so if x minus 1, if C is negative and you're subtracting the C, then that is shifting to the right. Okay, so maybe on the what I wrote up here, this affects x sideways, and it is opposite of what you see. And when you're talking about the values on the outside, it's going to affect y exactly the way you see it. Okay, outside, you look at it, you do what you need to do exactly the way you see it. A is multiplying, it is going to stretch if it's a number greater than 1, because when you multiply by 3, you get bigger. When you have a number that is between 0 and 1, and you multiply by 1/3, guess what's going to happen? It's going to get smaller. If on the outside you're adding something, it's going up. If you're subtracting, it's going down. Everything on the inside is exactly opposite of what you do on the outside. Okay? Just like x and y are opposites of each other, the effect is opposite of each other as well. All right. Now, the d, which is on the outside, okay? If d is a positive, meaning we are adding a number, then it is shifting up by that number of units. And if d is negative, meaning we are subtracting a number, then we are shifting down by that many units. Okay, so I went through a very detailed explanation of all these. Now let's look at an example or two. If I have f of x is equal to, let's say the absolute value of x plus 3 minus 8. Okay, the plus 3 on the inside, because it's on the inside, it's going left and right, and we have to think the opposite of what we see. So instead of moving positive 3 units, meaning to the right, it's going to be the opposite. So this is left by 3 units. And this minus 8, because it's on the outside, it's going up or down, and we do exactly what it tells us. Minus 8 would go down, so we are going down 8 units. And that is my description of the shifting or transforming of this function. Okay, and let's say I have g of x is equal to negative 2 times the square root of 4x minus 5 plus 2. Okay, this has everything going on. So this is reflecting, and it's on the outside, so it's reflecting up and down across the x-axis. So this is reflecting across the x-axis. The 2 is greater than 1, so this is stretching again, vertically, up and down. So vertically by a factor of 2. Okay. Also on the outside is this plus 2. So this is shifting up 2 units. Okay, those are all the vertical transformations. Now let's look on the inside for our horizontal. So the 4, now we're on the inside, so we do opposite of what we think. So it's not stretching, it's shrinking. So this is shrinking horizontally by a factor of the reciprocals of 4, so 1/4, by a factor of 1/4. And then the -5 is going to be opposite, so right 5 units. So this is shifting right 5 units. Okay, so that's essentially what you will be doing when you are describing the shifting of the graph. There will be times when you're looking at the graph and you have to um, identify the function, or you have to come up with a equation or function that represents the shifting that happens of the graph. Okay. All right. Now let's look at the backside of this, and here we are just basically looking at this in a general sense of any function, and our function here in my examples are just f of x. So it's not saying it's square root of x, it's not saying it's x squared, it's not saying absolute value, it's just saying if we have a function, okay? And a lot of these are going to relate to the same things we just did on the other side, okay? This c, when it's on the outside of the function, that's like on the other side of, or the first page here, when you had 2 times my x squared. That 2 was not actually inside of the function of this expression. It was in front of the function. So when we say the 2, or the c, in front of f of x, that's what we're saying. It is vertical. Anything that is outside of the f of x here is the vertical. If it's inside the parentheses here, that is the horizontal. And same thing as the first page. If it's on the outside, it's exactly what you see, and you're going to apply it that way. If you're multiplying by a large number, that is where the absolute value is greater than 1, you're going to make it bigger. You're stretching it. If you're on the inside, anything you do is opposite. Okay? All right. So the c out front, if we had 1/4, I'm sorry, going back to the first one here. If we have 2, a number greater than 1, then we are stretching vertically by a factor of c. And that really should be the absolute value of c. And here, if the absolute value of c is in between 0 and 1, we are shrinking vertically by a factor of c. When we have a negative number out in front, that is reflecting vertically, but it is reflecting across the x-axis. Looking on the inside, if that value of c, absolute value of c, is greater than 1, this is shrinking horizontally by a factor of the reciprocal value of c. So like this would, in my example, this would be shrinking by 1/2, by a factor of 1/2. Up here, this would be shrinking by a factor of 1/4. This would be stretching by a factor of 2. Down here, when my C is on the inside and I have a absolute value of C is between 0 and 1, this is going to be stretching by a factor of 3 in my example here. So when I have C on the inside between 0 and 1, this is stretching horizontally by a factor of the reciprocal value of C. So like the 1/3, I'm stretching by a factor of 3. Okay. If I have a negative on the inside, it is reflecting horizontally, so across the y-axis. If I'm adding on the inside, that is going to shift to the left that number of units. So shift left by C units. In my example here, I would be shifting left by 4 units. If I'm subtracting a number on the inside, that's going to the right by that number of units. So shift right by C units. And in my example, I would be shifting to the right by 1 unit. On the outside here, adding, I'm shifting up by C units. And in my example, that would be 8. So I'm shifting up 8 units. And if you're subtracting, that is shifting down by C units. And with my example, that would be down 5 units. Okay, so let's look at a couple examples. So if I have 3f of x minus 2 plus 5, I've got two numbers on the outside affecting this vertically. So the 3 is a multiplier, so this is stretching by a factor of 3. I am shifting up by 5, so 5 units. And with the 2 on the inside, that is a horizontal, and we look at it as an opposite value. So positive 2 would be to the right 2 units. So thinking opposite of negative 2, that is shift right 2 units. All right. And if I look at, let's see, negative f of, let's see, 1/3 x plus 3. No, I don't want 3. Let's do 5. Okay, this negative on the outside would reflect vertically. So this reflects across the x-axis. With the plus 5, that is shifting up 5. That's funny, I used the same number as I did up there. This is shifting up by 5 units. And with the 1/3 on the inside, okay, that is a multiplier. And I take the reciprocal value of the 1/3 as a 3, and that's going to stretch horizontally by a factor of 3. Okay, so that's what you're doing as far as understanding the transformations. And that's it for 3.4 day 1.